So the topic of today's lesson is qualitative analysis. And so before we dig any further, I want to make sure that you understand that this is a method of identifying the presence of certain ions. And so, and that's typically what we would consider qualitative analysis to involve. And so let's just take a minute to think about what the meaning of the word qualitative is. So in the word qualitative, we sort of see the root word quality. So what we're talking about here is identifying a chemical species, analyzing a chemical species by examining its qualities or its visible characteristics. So we're not looking at doing anything quantitative. We're not taking any measurements or doing any calculations. We're just going to be observing and recording what it is that we can perceive. So I want you to think about what types of tests that we've done so far that would allow us to identify the presence of a particular ion. And some of this should be familiar. So first of all, what we can do is we can look at the solution color or the precipitate color. So for instance, I know when I'm looking in our back room and I'm looking to find a solution of copper 2, then what I'm looking for is this wonderful light blue color. A telltale sign that I might have an iron 3+ solution, so like iron 3 nitrate or something of that nature, is this sort of like yellowy brown sort of color. And lastly, of my examples, this beautiful, lovely purple color is can be an indication that what you're looking at is a permanganate solution. But I wanted to highlight for you that if you look in the very back of your textbook, or Nelson Chemistry 11, what you'll find is a table. And that table tells you, based on the ion, what we would expect the color of the solution to be. So notice they would say that groups 1, 2, and 17 would all be colorless. But there are some other, especially in particular, transition metals with very particular identifiable colors. So moving right along, let's think about some other ways that we can identify the presence of certain ions. I want you to think back to one of our first experiments in this class where we did flame tests. And we could identify flame based on the color of the flame, what a particular metal ion was. So for instance, most of you will remember the lithium and the strontium being those beautiful reddish colors, reddish and like a fuchsia color. And maybe even the potassium, which was sort of like a violet lavender color. And then our copper ion, which was that bluey green sort of color. The back of your textbook also has a table that identifies flame color as well, because that is a way that we can, that's one method of qualitative analysis, looking at the color that we perceive of that flame. Now, the last topic, or the last method of qualitative analysis that I want to discuss is looking at a substance's solubility. And that's solubility in water, in an aqueous solution. So for that, we're going to need our solubilities chart. And I just want to take a minute to make sure that you can find that in the back of your textbook and that you are oriented with respect to how to use it. So first of all, you'll notice that on the heading on the top here, we see all the anions. And then on the side here, we have the cations. And so with respect to the cations, those that have high solubility are very, very soluble. We would consider them to make aqueous solutions. And those with low solubility, we would say are insoluble and form solid precipitates. So for instance, if I were to ask you about the solubility of a particular substance like AgS2SO4, silver sulfate, I would say, okay, well, here is sulfate. And here is silver. So silver and sulfate together make something with low solubility. So it would form a solid precipitate in solution. So let's look at a couple of examples. We're going to use our solubility chart to essentially analyze which cation and anion combinations are going to be insoluble, and not versus soluble. And that's going to help us identify maybe perhaps the presence of a particular cation. Because they're going to precipitate out of solution if they're insoluble. So let's look at a typical example. So I'm going to start us off with a fairly straightforward one. So I want you to envision that you have two solutions. You've made just in the lab, you've just gone ahead and you've made two solutions. One of them has barium ions and the other one has potassium ions, but you forgot to label them. So bad practice from a chemistry perspective, but it happens. And so now you're wondering, well, the solutions that you made were both aqueous and they look identical. So how do you remember which one is which? Well, that's what we're going to talk about next. So I want you to think about what test you could perform to figure out which one is which. So I've moved to my trusty Jamboard, and we're going to work this question out together. So I'm hopeful that you thought of, well, if one of these is barium and one of these is potassium, then what we're going to try to do is we're going to try to add the same substance to each of these, and possibly it will cause a precipitate in one of them, but maybe no precipitate in the other one. That's kind of what I'm going for. A couple of the reminders about the solubility chart. So notice, and that this may save you, I don't know, maybe 10 seconds or so, but those seconds do add up, particularly if you're writing a test or a quiz. So I want you to remember that all nitrates are always soluble. And I also want you to remember that all group 1 compounds, so our alkali metals, including acids, and all ammonium compounds have high solubility in water. In other words, compounds that contain group 1 elements or ammonium are going to have very high solubility in water. They're always going to form aqueous solutions. So let's take a look at the chart here and see if we can pick out an ion to add, or a compound, a solution to add to both of these, to see if it will cause precipitation in one and not the other. So my experience tells me that I'm not going to find any ion that is going to precipitate out potassium, because potassium is a group 1 element, okay? And so those are going to be always soluble. So what I'm really looking for here, therefore, is to find a particular anion that's going to cause barium to precipitate out of solution, barium 2+. So there may be multiple answers here. Maybe take a minute, pause the video, and see if you can figure out what an appropriate compound to add would be. So I am perusing, and I'm noticing that when I look here, I can see that barium, right here, is insoluble with sulfate. So to me, I would say, well, I'm going to add some kind of compound that contains sulfate to both of those. And one of them is going to precipitate out, and one of them is not going to form a precipitate. The one that forms a precipitate, it's going to form barium sulfate, because barium, along those barium ions in solution, are going to be insoluble when they combine with our sulfate ion, and that's going to make a precipitate in the bottom of our solution. Whereas the container that contains the potassium ions is not going to precipitate out. It's just going to look like a nice, clear, colorless solution, that's going to be the one that contains my potassium ion. So by adding sulfate, I'm going to cause the precipitation of my barium ions, but not my potassium ions. And so that would allow me to discover which one was which. Now, what are some other possibilities? Well, I see that sulfate is insoluble with most. So is hydroxide. Same with all of these cation or anions as well. So those would have also been some good choices to add in instead of my sulfate. So if you chose that, then you're in good shape. Okay, let's look at another example. But before that, I want to point out to you that when I go look in my, my chemical cabinet in the back room there, when I'm looking at my chemical cabinet, I'm not going to find, like, say, for instance, sulfate on its own. I'm going to have to find it in compound form. So I always want to choose some kind of a counter ion that is going to be soluble, because I don't want it to interfere with the precipitation, right? So I know that if I have, let's say, a cation, that I'm going to want to choose a cation that is always soluble. And I know my cation is always like a group 1 element. So Na plus is a good counter ion to add. If, for instance, you're looking to add some Cl minus. For anions, a good one to add would be NaNO3, nitrate, because nitrates are always soluble. So what do I mean by this? Well, in the last question where we had to add sulfate to our 2 beakers, I'm not actually going to be able to add sulfate because I can't find sulfate on its own. I need to find it in compound form. But what I want to do is I want to make sure that I'm adding in something that's in compound form that's not where the cation is not going to cause the precipitation. And so the good one to use there would be sodium. So an appropriate compound for me to have added in the last question would be sodium sulfate, because I know that the sulfate's going to go in solution and precipitate out my barium ions, forming barium sulfate, but this sodium is going to remain dissolved in solution. Okay, so let's look at an example. And if that part's not clear, feel free to pop into my Zoom meeting to clarify, and I'll expand on that. So in this question, it says, how would you separate the ions in a solution that contain Pb2+, Ag+, and Ba2+? So what we're talking about here is a situation where I've got my Pb2+ in here, I've got the Ag+, and I've got Ba2+ in here. I've got all 3 of those ions swimming around dissolved in solution. So maybe I found, maybe I use the nitrates of each of these solutions, because nitrates are always soluble and they're floating around in solution. But I accidentally put them together, and I really should have put them maybe in separate containers. So what kind of strategy can I use? How can I use the solubility chart, moreover, to help me separate these ions? So what I want you to do is to pause the video and give this a try and see if you can come up with a solution. Okay, so this is going to be a stepwise process. And so I like to think of this in terms of a nice sort of tree diagram or flow chart. And so that's how I'm going to do it. So we start with all 3 of our ions. I've got my lead, I've got my silver, and I've got my barium. And I'm going to add something to it that's going to cause one of them to precipitate out, and then I can just sort of filter. Okay, so let me just backtrack on that for 1 second here. So I'm going to look at my solubility chart and see what substance will precipitate out one of them but not the other. So if I look at any of the chlorides, bromides, iodides, any of the halides, if I added a halide ion, then that would precipitate out silver, but it would also precipitate out lead at the same time. So that's no good, because then these two would be stuck together and I wouldn't be able to separate them once they're in solid form, right? So that's no good. I can't use chloride. So then I'm looking over and, you know, most, that's no good. Most, that's no good. Except that I'm seeing that barium right here is soluble with hydroxide, but it's not soluble with the other two. So if I were to add hydroxide in, then the barium would remain aqueous, but my silver and my lead would still would precipitate out of solution. So they would be combined in solution, and that would be, or out of solution, and that is no good. That's not what I want. So moving on, let's look at sulfate here. So if I look at sulfate, sulfate is going to also precipitate out both silver and lead and barium, all three of them together. And then there's still, I'm no further ahead. I've precipitated out all of them, and that is no good. So I've just gone over here and I've noticed that acetate right here will precipitate only silver, and that works out perfectly. So that's actually going to be my first step. I'm going to add acetate, but I'm going to add sodium acetate because, again, I'm not going to find acetate all on its own. Okay. So when I add acetate, acetate is going to cause a couple of different things to happen. The acetate is going to cause something to precipitate out, and then a couple of other things to not precipitate. Now, the whole point of me adding the acetate was to precipitate out my silver. So I'm going to have a precipitate of silver acetate. So that's separated. But what I'll still have remaining are my lead ions and my barium ions. And now I need to sort out a way to separate them. And so I'm sort of starting over, but I only need to focus on a substance that will precipitate one of these, but not the other. And so since I've gotten rid of my silver, I have a couple of choices. I have many choices, actually. But I'm going to just choose one that works, but there are other options, just so that you're aware. There's no one good and only solution. I'm noticing right here that, I'm going to do this part in green, I think, that, my lead can be separated out with any of these ions. So I'm going to choose adding chloride. So I am going to add in sodium chloride. And the sodium chloride is going to cause a precipitate with my lead, but not with my barium. So I'm going to have a precipitate of lead chloride, and I'm going to have just a solution of Ba2+. And at this point I can stop, because my goal was to separate the ions, not to precipitate them out. And so in this question, I was able to do that, right? So let's just kind of go back and go over this. So in the first step, I added the acetate because the acetate would precipitate out my silver and separate it out. Okay, so maybe I would filter out that solid or something to that effect. And then it's gone. And then what would remain in that solution that would remain after I filtered would be my remaining two ions. And now to separate them, I would add my sodium chloride, because chloride is going to precipitate out my lead, but it's not going to precipitate out my barium. So that gives me lead chloride, and I filter that lead chloride out, and that will give me a solution of barium ions all separated. So I've accomplished my task. So this is, a stepwise process that may be confusing. If you need me to go through this and explain it in more detail, feel free to pop into my Zoom meeting, and I'll be more than happy to oblige you with respect to that.